Hello, Vin. How are you?
I'm good. How are you? Thanks for having me.
Yeah, thank you for joining the podcast. I'm really happy to have you because I've been following your course. I've been like looking at your content and learning from you for a long time. So I want to state the objective of the podcast. Um, it's called Dream for Data Rules Everything Around Me. And it's a fun name for describing the environment we are in, you and me, and all the other professionals that I try to interview. The main idea is to divide the conversation into three main areas, three main questions. One being, what's your story? Where do you come from? Um, I might have tricky question. What's your mission? What's your mission? Your vision? Your drive? What's your motivation on the daily basis? And what's your vision of the future? How do you envision the future in the area of data and AI? But more generally, I mean, we can go sideways. We can just jump around. The conversation is meant to be like if we were having a conversation and having a classic kind of discussion about anything around data life. So be free, like be completely free from whatever you want to say and expose. I'm not going to precisely come back with questions, but we are going to try to keep that open through the whole 30, 40 minutes that we are going to have this conversation. Okay for you?
Sounds great. Yeah, sounds
Great.
great.
Cool. Cool. So first things first, Vin, who are you?
I am Vin Vashishta and founder of V Squared. It's one of the oldest data science consulting companies really in the world today. I do AI advisory services now, but we started out as an R&D consulting company. So we were building product back in 2012 when no one knew what data science was. But even before that, I wanted to get into machine learning. And I tragically showed up in the 90s when we had our first little peak and trough and interest disappeared. So it was good to be on the front end of it, sort of the leading edge. And now being in front of data and AI strategy, productization, monetization, trying to turn all of this technology into cash for businesses, figure out what to do with it so that we can build all that cool stuff for customers.
Mm-hmm.
Having a lot of fun with it. I do content creation, I teach, got a book. Yeah, doing a lot of stuff right now. Keeping busy.
Yeah, yeah, I've followed you for I don't know 1 2 years maybe, and it's been impressive to see the consistency you're in. Like you're always pushing, always delivering, and it's really inspiring to see that. So I want to understand a bit more about you. Obviously, like what kind of brain do that? Like how intensely can you go and concentrate on those kinds of topic for years and years and years is really something that I want to dig into. So probably a question that I like to ask is
Yep.
um, who was Vin as a child? Like what kind of child were you?
I was a pain, a giant pain. I mean,
Good.
you start out life sort of understanding who you're going to become, not what you'll do, but it's pretty easy to figure out what your personality is. And I was always just driven. And that's been something that's been with me my entire life. My parents gave it to me. They encouraged it and nurtured it. And they explained how important it is to have that drive. And part of drive is just consistency. And through, in my childhood, drive was just doing as much stuff as I could, having as much fun as I could,
Mm.
trying out everything that was put in front of me. It was, yeah, as a kid, I was terrible in every way, and I don't know how my parents survived me, but they're still with us, fortunately. They made it through my childhood.
Good, good, good. So where did you grow up? What was the environment you grew up in? Like,
Born and raised in Honolulu, Hawaii, so a very
ooh,
small island, middle of the Pacific. Really great place to grow up in some ways, but also bad because you are landlocked and you feel it. You are
mm,
sort of surrounded by the ocean, and it feels smaller than the island really is. And I think all of us have this drive to get out and see what else is out there. And for me,
mm,
that was what took me away from home. went to school in Hawaii, grew up on Oahu, went to high school on Maui, and then eventually went to University of Hawaii for a year and moved to Reno right after that. I needed something new, something different.
Okay. And Reno is where you still are today?
Still here.
Yeah. Okay, good. So you settled mainland
Yep.
and yeah. So when was that? Like the moment where you started like settling up over there?
1995.
Ah, okay. And so you were already like graduated and everything, like
No, I came here for undergrad.
oh, undergrad. Okay.
Yep.
Okay. And so the what does the scholar like route that you took was like? Did you already knew that you liked uh, this aspect of, I don't know what we can call it, like mathematics, science, a bit of both, like a bit of business, because you're really touching different subjects. So tell me more about that. Well, how did you figure that out?
I was a terrible student, and I tried to get out of college as fast as humanly possible.
Okay.
I started out going for civil engineering. So I got a couple of years of solid engineering background. Took some software engineering programming courses, and
Hmm.
that really made me realize I liked the programming better than I liked civil engineering. And so I switched. And when I came into the College of Computer Science at UNR, they had just gotten a grant from Microsoft to teach machine vision and some basic machine learning techniques. And so I got to take three different courses on machine learning back in the 90s when machine learning was, oh, it was terrible. It was so painful. I can see why,
Can you describe like how was that? Like you had seven
oh,
backend. Like what does it like?
back end? No, we had, I mean, we had barely enough drive space to put anything on. We had no RAM in any, I mean, just no compute, no RAM, no nothing. We had to build our own filters. If you can think of, computer vision today, the filters are sort of built automatically by the model. We built
Hmm.
our own filters and then used, that's how bad it was. We couldn't use any more advanced because the compute just wasn't there. So you had to build your own filters. You had to sort of manually figure it out yourself. You didn't have a whole lot of
Oh.
data to learn from. And so doing edge detection was hard. I was just also natural language was a nightmare. I mean, it wasn't something that you could do very well. It was over glorified, counting terms. That's really what NLP was back then. It's tokens, yeah, not, 1 gram. That's all you could, n-gram, no, one. You had words, that was it. You couldn't do,
I see.
two, three, four. You couldn't do phrases. You couldn't do too much predictive, like what we're doing with generative model. You couldn't do any of that. It was as
Hmm.
remedial as you could think about it. Regression, clustering, but that was the nice thing is we had a lot of the foundational, what I call the bases of data science. Those really, that everybody
Fundamentals.
uses them. Yeah, we had those back then. So I got to learn fundamental data science, even though we could do very, very little with it. And so it was just the technology that I had to learn and pick up once 2010 is really when we had enough compute and we had enough horsepower to do more complex machine learning, deep learning.
Great. But so it was. It should have been super like interesting at that time because the hardware, the was not there. The data was not there.
Nope,
The
nothing,
algorithm were like
nothing.
beginning.
Yeah, a
So
gigabyte of data was unimaginable. It truly was. That was too much data for you to really be
mm,
working with. You couldn't do anything with that much data, so you were very, very constrained. The models you could use, you had to optimize using C or C++ because your
I see.
compute was just so constrained. Didn't have cloud. Distributed was, I mean, we had, networks that we would build to do distributed, but doing that was painful. There was no open source frameworks that you could implement. So we were really missing a lot of the pieces. We had
But
some of the models, but the compute side of it and the hardware,
yeah.
no, it just wasn't there.
Because the funny thing is, like, when we talk to experts that have been in the game for a long time, like you,
Mhm,
it seems like the fundamentals were there and didn't
mhm.
really change, but it's just the more compute, more data,
Yep.
but there's still the same fundamental. Is that right?
It really was. I think in 2017 was when we began to see new approaches that were feasible to implement and better than what we had, better than the alternatives of your basic methods. And that's where I think we saw a switch from everything is fundamentals and everything can be accomplished with uh, model architectures that we've had for a very long time to 2016, 2017, we began to see new architectures that were improvements, not iterations. So there were definitely optimizations and there were groundbreaking papers that were published, obviously, before 2017. But it felt like 2016 and 2017 was that tipping point where deep learning and more advanced methods finally, I don't know, were defined better and in ways that we could use them, deploy them successfully.
So we're talking about the Transformers paper, for example,
That's
the
one. Yeah,
Transformers architecture.
definitely. Yep.
Okay. So you saw really a change. That's interesting. You saw really a change between everything that was before that and the moment where finally everything comes together, like research
Yep.
kind of consolidate into some kind of basic principles that everybody can agree on, and that's what you're saying, right?
Yeah, we started seeing research on transformers. We started seeing reinforcement learning for machines and mechanical use cases. Transformers obviously. Started seeing causal and federated learning. Those all began to gel into something feasible that you could implement, and it was reliable enough that you could commercialize it in a lot of cases.
Okay. So that's the big change. All right.
Yep. Yeah, the research was useful, but it was incremental and it was very academic versus applied and something that you could put into production. There were definitely
Okay.
papers before that you could implement parts of, but more times than not, the state of the art sort of claims that were made, you didn't have anything living up to that expectation. When you implemented the papers, there was always something missing. There were gaps. You had to do a lot of work on your own and there were always additional pieces that you had to put in place, and sometimes they weren't feasible to truly implement and deploy.
I see. So I guess that this is the moment, probably a defining moment. I'm assuming that for you when you saw like,
Yep.
okay, now we can do business with this.
I think we underestimate how much value you can get with those foundational models. I say this a lot, ride the regression pony until the wheels fall off, because you
Oh,
can get so much value out of simplistic methods. Don't give up on clustering. Don't give up on your
hmm.
simplistic, straightforward approaches because they're cheap, they're easy to deploy, they're explainable, and they're
Yeah.
very reliable in a lot of cases.
So we are talking about K-mean,
Yeah,
XJ boost, and that sort of
sure.
stuff.
Yep. Yeah, just very, very basic, fundamental machine learning concepts.
Hmm.
If I was using those between 2012 and even to today, I still use them. It's so
Hmm.
valuable and so fast. That's what the benefit is. You don't need a ton of data if it's well structured, and you can get genuine insights, deliver features very, very quickly, iterate on those features. And if it makes sense, why not, use something more advanced? But if you deliver quickly, what you find with businesses is that they give you more work. Why? Because you're creating value quickly. So I talk
Yeah.
about this a lot in my courses. Don't abandon those simplistic descriptive models because you get so much value out of them. And more times than
Hmm.
not, the descriptive model finds patterns in complex data. And people are really bad once you start adding a ton of features or once you start talking about longer time scales. We're really bad at finding those complex types of patterns, but simple models find them immediately. And so you can go from a bit of data and a simple model to something that's meaningful, either automation wise or providing data for decision support. You can provide a significant amount of value with those simple models before you go all in and do something more complex and more expensive.
Yeah, I agree. When I was working in treasury, also the good stuff that were immediately providing value were using like simple linear regression.
Yep. Yeah.
That's it.
Yeah.
You
Just
start
ride the
like downloading
regression
a
pony. Yep.
package.
Yep.
Yeah, that's it. And you show. I was the first time I showed that to my boss. It was funny. Like, oh, okay, so we can do that. Okay. That's
Yeah.
not a big, like far away thing that we would do eventually when we will have a data team. We can
Yep.
actually do that right now. It's just some code.
Yeah.
That's
Import from,
yeah,
that's the great thing about
yeah,
Python. And I used to hate
yeah.
Python. And then there were just so many libraries and it was so simple. And, aside from package management, it's still a good language. I mean, I think everybody universally hates package management, but
Yeah.
everything else about it, aside from the dependencies, is really straightforward, easy to pick up, and you can do a lot of machine learning very quickly.
Hmm. It was so eye-opening for me, like when
Yep.
it was 2016 when I started saying, wow, all these open source libraries available for free.
Yeah, yeah. Why not use
What?
it?
Yeah, why not use it? Yeah, sure, sure. So that's that. I think that like talking about the algorithm is obviously the easy part
Yep,
because the big thing is the data and the business use of that data essentially. So
yep,
I want to go into this topic because you have been a big advocate of like data for business use for transformation to cash. I'm also coming from that lens, so this message you shared resonated very, very loudly in my head also. So can we talk about this like drive that you have, and how did you realize was there an epiphany moment where coming from the technical side you were like, okay, now I get it, that we need to switch the gears and go toward more business discussions? Like, can you share about your journey to that realization?
For me, it was really I would say the first 4 years of working in the field where the only data you had was trash. And I think that was universally true up
Hmm.
and until about 2016, 2017, where some businesses began to gather data in a more rigorous way. But before that, almost everything you had was terrible. It wasn't formatted in the right way, it wasn't gathered in the right way. The quality was terrible. And so, what I realized is when I went from having low quality data to owning the data gathering process, it took way less data to train a model than it did in the past. And for me,
Hmm.
that was the epiphany. Is I started looking at how much it cost to gather data right the first time versus just taking what we have and trying to throw a massive model at it, or trying to throw a massive amount of data at a normal model. And it was so much more expensive, and the result wasn't as reliable as what I got when I structured the data. So I sort of just started iterating on that and saying, okay, what is the absolute best possible where I can use the smallest model, the least data, and get the most functionality, the most reliability out of it. And that's where, like I said, I just sort of iterated through it and realized that there was an entire field of information science that talked about, instead of data management and data engineering, it was knowledge management and engineering knowledge
Mm.
systems. And when I ran into that, I thought, wow, we are really, we're reinventing the wheel. It's already out there. We already have an entire science and discipline that's been dedicated to this. Why not just use the fundamentals that they've built and modify them a little bit for data science, for machine learning, and for enterprises? Because a
Interesting.
lot of information
Interesting.
science isn't feasible at an enterprise level. It's feasible at an academic level, but enterprises don't need the same level of rigor. And when you think about it this way, and you say,
Good.
okay, so we can kind of bend some rules and cheat a little bit. We don't have to do this in a way that's publishable. We're really just looking to make business impact. And when you shift to the
Hmm.
outcomes, suddenly you can implement these, information science components and ideas in a way that's more feasible from a cost perspective. And it brings the cost of data science and machine learning down so much, and we can deliver so much faster that it's just, as soon as you see the difference, you don't go back. You never ever touch data that was gathered for, for BI or something like that, because it's so bad and it's so expensive and it takes so long, whereas you can deliver so much faster with better data.
I see. Yeah, it's like you can take the data where it is,
Yep.
plug into it, and then gets the value. It sounds like there's a big word like data mesh structure that comes often into the discussion. I guess that we are in fact kind of talking about it like go where you know that you have the good source
Yep.
and figure out how to get that data to your data product. Maybe we can also start talking about data products and the importance of data products. But like what you're saying here, just to make sure I understand, is that this information science field, knowledge management field, is kind of this scientific way of mapping the world and how it works, right?
Yep.
It's like, is it like, to me, it triggers the word of ontologies and everything. Can we like, is that what we are referring to?
Yeah, that's the direction I think we're all going in. There's a number of
Yeah.
companies that are building ontologies internally, and it's not just the ones that you would expect, where you're talking about big tech. I know companies like
Hmm.
Capital One and Lennar are both working on it. So it's big tech, but it's also more traditional companies. And if you look at what Palantir offers, they've got a product called Foundry, and underneath Foundry is this concept of the ontology. And it's something that they
Yeah.
offer to, widely to their clients. SAP has a knowledge graph at the bottom of their new data platform. And so they're integrating it and rolling it out to customers. This is sort of, it started out sounding fringe, but ontologies and knowledge graphs are now becoming mainstream because they are the most efficient way to store data with the purpose of training a model, not serving it to a person who already knows what to do with the data. The model has to figure that out. And if you create, we call it metadata, but really what it is context. It's
Yeah.
context about whatever it is
Context.
that generated the data. So it could be business context, could be customer context. We could be talking about machines on an assembly line and understanding what machine created it and what the machine was doing at the time that it created it. How did the
Yeah.
customer create this data? What was the customer doing at the time of creating this data? How does that connect with other steps? How does that step that generated that data connect with another step or another activity that and the data that it creates? And once you create those linkages, now you have context. And so if the model wants to learn something, feature engineering gets a whole lot easier because by looking at the connectivity between concepts and then the data that's gathered and associated with each one of
You
those
can just
concepts. Yeah, exactly. You just walk up the
you
graph
can get
and
the yeah. I see. You really navigate the why
yep.
more easily.
Yeah, and like I said, feature engineering is the first beneficiary. We go from I don't know what data is available and I don't know what data is relevant to being able to use those basic concepts to say this is the workflow I'm working on or this is the system that I'm interested in understanding better. And here are all the data points that we gather from that system. And
Hmm.
so this is probably the most relevant data to what I'm trying to understand. And you're doing modeling in a more rigorous way, not just data modeling, but also modeling that system. We're doing it in a more
Knowledge.
scientific, more rigorous way. Exactly. We're trying to extract knowledge from the data, not simply trying to extract basic patterns. This is something that's a little bit deeper,
Yeah.
more complex. And if you're capturing data correctly, this is actually pretty easy to do. It is simpler than trying to get it from massive, massive amounts of data. So instead of putting all the work into the model, you're sort of splitting the work up between data generation and capturing based on data generating processes, and then eventually engineering data generating processes so that data sets you do not have but you need, you can engineer a process that generates the data for you and you can now add those concepts that could be gaps, could be areas where you didn't have that data.
Yeah.
Now you're being really intentional about data gathering with respect to a system that you want to model. And when you approach
Yeah.
it that way,
Intentional is the word.
yep, yeah, when you approach it that way, it is so much simpler and you don't have as many iterations to get to a reliable model because you're already sort of zeroed in on what's important.
Yeah. And you get straight to the business value.
Yep, exactly.
Like you take the topic upside down. You can really like, oh, what's the delivery line?
Yep.
Let's engineer this all back
Yeah,
and not
and
go
that's
from, oh, the data is messy, I don't know what I'm gonna do with it, and then I'm gonna just do a bunch of table and storing and adding things. Yeah, I see exactly what you mean.
yeah, it's the
Obviously, like
connectivity.
this is yeah,
Yeah, it's the
connectivity part.
connectivity back
Connect
to the
everything.
value. Yeah, this is what the
Yeah,
business cares about, so let's model what the business cares about. And you're never
yeah,
disconnected from the need because you're either looking at the customer's process, whatever the customer's doing that generates the data, or the business process, whatever the data the business is doing that's generating the data, or the
yeah.
marketplace, whatever the marketplace is doing that generates the data, or whatever the system is that you're trying to model. As long as you stay close to that system and the business says this is a valuable system to understand, to automate, to whatever it is, then you
Hmm.
never go beyond what creates value. You always have that stable connection back to it.
Great. So it makes me think of a lot of things, obviously, but one is the system part and engineering systems, and
Hmm.
what does that exactly mean in the grand scheme of things. We've been not treating data as a product so far, but you've been a big advocate of this. There is other like Harvard and Harvard Business Review articles from a year ago, McKinsey, yeah, like you name it. You've been talking about it for a long time, but those guys also have like followed up and trying to put that into that direction. I see a little bit less of this right now with the GPTs
Yep.
coming in and this assistant, but those are eventually the same thing. They are
Yep.
data products.
Yes.
So like, can we talk a bit about that? Like, and the need to probably, I want to just go twist this to, um, you're a business owner,
Hmm.
um, because for me, it's coming from that place, right? You're a business owner, you're already making the connections between all your departments. You're
Yep.
already doing it in your head. You know, department X, department Y is connected to this, but you don't necessarily know how to formalize it. And that's a pain because you always need to teach your different department and head
Yes.
offs like, okay, this is what I mean by that. This is how this connects to this is connected to that. So for me, the business leader mind mapping and understanding kind of draws naturally into data products and how those different products needs to be engineered, how they can eventually connect to each other. Um, is there a concrete path forward that one company can take to go from I don't have a roadmap, I don't know how to use AI and data to I have my marketplace of assistant agent data products. What's your vision around it? Like, can we deep dive a little bit more about that? Because I think it's most of the vision that you have and you've tried to nail for a few months now is this forward-looking vision to an agentic kind of world where different data products communicate with each other. And I want to take some time to like get your thoughts on this.
Yeah, it's so we're in an interesting place because we have some businesses that are still struggling with data, and we have other businesses who are deploying multiple agents into production and starting to
Hmm.
understand what a multi-agent platform looks like. So we're going to quickly see this separation of companies who can execute using more advanced technologies, but more than that, companies that can monetize them. Because a lot of the missteps we're seeing are from companies that put something out, put a product out, put something out internally to improve productivity, and it misses the mark. It doesn't do what they claim it does. It's not reliable enough. It isn't functional enough. It doesn't really map to a workflow, or it misunderstands the workflow and ends up having unintended consequences. So there's two sides to this equation. We have a technology problem on one side, and we have a monetization problem on the other side. Both of
Yeah.
them need to start at the very beginning, where you do opportunity discovery and you figure out what should the business be doing. Right now, business leaders are saying, just tell me what to do, and that's the wrong approach. Start with the business, not the technology. And this works for generative AI, multi-agent systems, but it also works for data. What data should we gather? Well, as a business, what is the most valuable process that you have? What are your most valuable products? What are the features that you need to deliver but you can't? Well, that's where you need to begin to start gathering data with the intent of productization. So you do that product first thinking. And this is really, when you talk about my vision for where we go, you have to start at the ground floor, because that's where so many
Mm.
businesses are. And if we don't meet businesses where we are, if we tell them you have to be this, you have to be Google, that's just not
Yeah.
feasible. That's not
Not possible.
that's not the reality. So we have to create a path
Hmm.
forward for businesses that's pragmatic. And I've got the
Yeah.
maturity models, I've got all the frameworks from my book, all the ones that I teach in courses, that take you from opportunity discovery to putting something in production and iterating on it every quarter, delivering value. And so you're meeting investor needs, you're meeting the business's need, but you're also creating an alignment. And that's really what we're talking about when I say what's my vision for the future, is we need an alignment. All of these features have to roll up into something, they have to roll up into a product. And one product
Hmm.
eventually will not be enough for the business. And so it needs a platform that enables the business to iterate and build new products. It makes it less expensive, it makes it faster. So we have to redefine architecture, building today for what we know is coming. So instead of building today for what we're building today, we have to build today knowing that there's multiple technologies, we'll implement multiple technologies, technology will continue to change and evolve, but we have basic understandings of first principles. What technologies are coming? What are the implications of each one of those that are straightforward? And what should we be doing in order to prepare for that? And so my vision
Yeah.
really is a different type of enterprise that has three fundamental foundational components. You have your business model, your operating
Okay.
model, and a new one, which is the technology model. And when we start in just intentionally moving pieces from the business model, the operating model into the technology model, or deciding to make parts of the business for the first time with technology, creating parts of the product, creating parts of the operations for the first time with technology, now we're starting this process differently. We're starting with business needs, not with a technology buzzword. And so that's, on the
Yeah.
business side and the monetization side, that's my vision for the future. We have to get there in order to get, sort of this grandiose vision that I have on the other side, which is multiple agents, where you have
Hmm.
your platform at the very top, and that is your interface with your customers. It is your interface with people internally too, because if you think about it, your product lives on the other side of your operating model. And as soon as you build
Exactly.
a platform, that becomes extremely evident, it becomes very obvious that you sort of have two sides to the business, one facing the customer, the other one we thought was just facing internally, but no, it is creating value that our customer consumes on the other side, which is the product. Once you see things that way, you start to realize that we just need a single interface to our customers. And that's something that generative AI does really, really well, is it creates that interface, and it's a new type of user interface. It could be an intelligent agent, an intelligent assistant, or it could simply be a way for the customer to say, this is my intent. And if you detect intent, it is just absolutely powerful, because now your customer doesn't need to understand the complexity that's going on under the surface. And you can make more complex systems because your customer never has to deal with or touch that complexity. And so you can
Yeah.
have all of these verticals underneath that interface layer. And generative AI is an amazing orchestration layer. And it can figure out where it needs to go, where this request needs to be routed. And this is where this multi-agent, multi-app, multi-technology environment comes into play. Does it need to use 4 apps to satisfy the customer's intent? Okay, the customer doesn't need to know that. They don't need to ever know that. They have a single interface to the product. And no matter what the product is, whether it's their phone or it is a B2B enterprise, system, doesn't matter. Single interface. Everything that's underneath it is orchestrated by one of your models or multiple models, and the customer never sees the complexity. So you can build more complex granular systems under the surface. What that means is your
That's the
models
thing.
don't have to do everything. Your apps don't have to do everything. You can have very specific purpose-built apps and purpose-built models. Why is that good? Because those models are cheaper. And when you begin to look at this from a perspective of reliability, they're also more reliable. Why? Because all you've trained them to do is a very specific set of tasks, or task domain is a good way to say it, but it's very narrowly defined. And so you don't need to train it to answer every single question possible. It's just designed to do a single task domain, a single set of steps, or a single knowledge graph, a very small part, very constrained part of the knowledge graph. And when you have appropriate constraints, these multi-agents increase reliability, but they also are so much more functional and so much faster to build. And this is that construct of multi-agent system. But it's sci-fi unless we give businesses a path to it. So,
Yeah,
it's not enough to just say, oh, there's this cool stuff that can happen. Right. But if there's no
yeah,
roadmap to it for businesses, if there's no plan to get from where they are to that, we've sort of failed, haven't we? And that's what a lot of the frameworks
yeah.
that I deliver are for. And that's why I always start talking about data, gathering data intentionally, building out the knowledge graphs, starting with small models, because now you're sort of seeing it. Those small models don't necessarily have to go away and be replaced by bigger ones. If they're really reliable and they focus, on a very small task domain, why not keep them? And just
Yeah.
build, just keep them and build on top of them. So this is an iterative way to deliver value where you can deliver quarter to quarter. It's not complex to begin with, but it is aligned on a roadmap that gets you to this sort of grand destination that's possible, and that will give you a genuine competitive advantage. It'll give you the ability to operate at lower cost and deliver functionality that your competitors can't keep up with.
That's amazing. And obviously, I listen to this as a student, but also as a builder and a CEO of that company that I've been like thinking about for a long time. That goes exactly that direction, and I'm so grateful that to have like thinkers and thought leaders like you that push in that direction. Because eventually, when people realize that like the game is really to how to map this CEO brain kind of
Yep.
thing and be your own CEO in any kind of situation, right? It's not about just serving the CEO. It's how do you become the CEO of your own like environment, connecting with your own
Yep.
agent, like be your own boss in a way,
Mm-hmm.
and because that can apply to different like perspectives in an organization.
Yep.
That's a really powerful story, and I am feeling like we are lucky to be able to do this now because
Yep.
everything that I've been seeing in the past in the corporate world is really disappointing in terms of like quality of support that we need from tech to accelerate business and solve problems, and there is so much to do. Like right now it feels like the past years before this new era for me was about like old school. Okay, that's so Excel, we need to copy paste data in such a way like
Yep.
that's like for me like entering the corporate market at that time was like crazy. Like okay, this is what the highest finance people are doing. Like excuse me, but it doesn't feel right. So I'm really grateful that this thing is happening now because eventually we can solve bigger problems and connect more stuff together, which is the essence of like working and creating value, right? It's like, how do
Yep.
you connect things together? So thank you so much for like bringing this perspective to the table, Vin. It's really good to be able to discuss around those topics with you. Um, I think it's wrapping up perfectly, like the discussion to finish on that. Do you want to add anything else? Like, do you want to like where can we reach you and how can we connect with you?
Yeah, datascience.vin. Everything that I have and offer as far as courses, the book, and support when it comes to workshops and seminars, you can find everything there from me. V squared, we're not accepting new clients yet. We're right now a little bit overbooked and we're onboarding people, so sorry. But hopefully Q3
Good.
we'll be bringing some new clients on in Q3, and we'll be back to a normal, functional, accepting new business again.
That's great.
Yep.
That's great. Sounds like a lot is going on.
Yes,
Excellent.
we are busy. It's a good thing though.
Yeah. Perfect. Thank you so much for taking the time in your busy schedule. Again, so grateful to have like leaders like you to look up to and to follow your lead and your ideas. I hope that this podcast will serve also a lot of other people. Have a good day, and I'll see you soon.
All right, take care. Thanks for having me.
Thank you so much, Vin. Bye.
Bye.